Have you ever wondered how many alien civilizations might be out there? This question has intrigued humanity for centuries. Long before the advent of telescopes, ancient philosophers were already speculating about the possibility of life beyond our world. Democritus, a philosopher of ancient Greece, proposed the idea of an infinite universe filled with innumerable worlds. Epicurus, another Greek philosopher, echoed this notion, speaking of countless worlds throughout the boundless immensity of space. These early thinkers set the stage for a long-standing debate about the existence of extraterrestrial life. Early Christian writers too engaged in this dialogue. They discussed the concept of a plurality of worlds as proposed by these earlier philosophers. Some even contemplated the possibility of Jesus visiting these extraterrestrial worlds to redeem their inhabitants, a notion acknowledged by the 15th century scholar William Vorilong. In the 1440s, Nicholas of Cusa, a German philosopher, theologian, and astronomer, furthered these speculations. He posited that Earth is a brilliant star similar to other celestial bodies visible in space. From an exterior perspective, Earth would appear akin to the Sun due to a layer of fiery brightness in the outer layer of the atmosphere. Cusa theorized that all extraterrestrial bodies, including the Sun, could host life, with men, plants, and animals inhabiting them. These early thinkers could only speculate, their theories limited by the knowledge and technology of their time. However, their curiosity and their belief in the possibility of life beyond Earth laid the groundwork for future exploration. It sparked a question that would endure through the ages. Are we alone in the universe? With the advent of modern technology, we've been able to move beyond mere speculation. We now have tools that allow us to explore the cosmos, to search for planets beyond our solar system, and to make more educated guesses about the possibility of alien life. The question, however, remains, how many alien civilizations might be out there? In 1961, a man named Frank Drake devised a formula that could potentially calculate the number of detectable civilizations in the Milky Way. This formula, known as the Drake equation, set the stage for an entirely new way of thinking about our place in the universe. The Drake equation is a string of variables that, when combined, give an estimate of the number of civilizations in our galaxy with which we could potentially make contact. It's not an exact science, but rather a way to frame our thinking about the search for extraterrestrial life. Let's break down the equation a bit. The first few variables include the rate of sun-like star formation, the fraction of those stars with planets, and the number of habitable worlds per stellar system. These are all factors that could contribute to the development of life as we know it. The rate of sun-like star formation is crucial because, as we understand it, life requires a stable, long-lived star at the center of its solar system. Our Sun is a perfect example of this. Next, we consider the fraction of those stars that have planets. This is important because without planets there can be no life, at least not in the sense that we understand it. Lastly, we consider the number of habitable worlds per stellar system. These would be planets or moons that are in the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist. For a long time, many of these variables were pure speculation. We had no way of knowing how many sun-like stars had planets, or how many of those planets might be habitable. But thanks to the tireless work of astronomers and the advent of powerful new technologies, we're starting to get a clearer picture. Until recently, many of these variables were unknown, but thanks to advancements in technology, we are starting to fill in the gaps. The Drake equation may not give us a definitive answer, but it provides us with a framework for understanding just how vast and diverse our universe might be. In 2009, NASA launched a spacecraft named Kepler with one primary goal: to determine how common planets like Earth are. As we journey through the cosmos, imagine a spacecraft that's been tirelessly gazing at the stars for almost a decade. That's Kepler, a silent sentinel in the vast expanse of space. Named after the 17th century astronomer Johannes Kepler, this spacecraft embarked on an epic mission to uncover Earth-like planets in the habitable zones of their stars, where conditions might be just right for life as we know it. These are the Goldilocks planets, not too hot, not too cold, but just right for liquid water to exist on their surfaces. Kepler worked by observing the brightness of stars. When a planet passes in front of a star, causes a slight dip in the star's brightness, a phenomenon known as a transit. By monitoring these transits, Kepler could identify potential exoplanets, or planets outside our solar system, and the sights it saw. By the end of its mission in 2018, Kepler had spotted some 2,800 exoplanets. These alien worlds ranged from rocky Earth-like planets to gas giants larger than Jupiter. Some orbited their stars in mere hours, while others took hundreds of Earth years to complete a single orbit. Many of these planets were nothing like the ones we have in our solar system, expanding our understanding of the universe and its infinite possibilities. Yet Kepler's mission wasn't just about quantity, it was about quality. It sought to find planets that are not just out there, but are also potentially habitable. And in its quest, it found numerous such candidates, tantalizing hints that we might not be alone in this vast universe. Kepler's mission, however, was not without challenges. It faced mechanical issues and survived several close calls. But each time it bounced back, ready to continue its exploration of the cosmos. Kepler's mission was a success, but there were still pieces of the puzzle missing. The Kepler spacecraft may have completed its mission, but its legacy lives on. It has opened our eyes to a universe teeming with planets, and has set the stage for future missions to further explore these distant worlds. Enter Gaia, a spacecraft launched by the European Space Agency, which monitors stars across the galaxy. Named after the ancient Greek goddess of Earth, Gaia is the celestial watchkeeper, keeping a careful eye on the heavens and gathering data about the stars scattered across our Milky Way. Its mission is no small feat. Gaia is tasked with creating the most accurate 3D map of our galaxy, cataloguing over 1 billion stars. But Gaia's role goes beyond mere cartography. It also monitors the brightness, temperature, and chemical composition of these distant suns. This meticulous data collection is not just for the sake of cosmic record-keeping. It is pivotal in helping us understand the prevalence of Earth-like planets in our galaxy. So, how does Gaia help in our search for Earth-like worlds? Well, Gaia doesn't directly detect exoplanets. Instead, it precisely measures the positions, distances, and motions of stars. When combined with the data from NASA's Kepler mission, it provides a powerful tool for estimating the number of potentially habitable planets. Kepler had already identified thousands of exoplanets by observing the tiny dips in starlight as these planets passed in front of their stars. However, to determine if these planets are Earth-like, we needed more information about the stars they orbit. That's where Gaia comes in. By providing detailed data about these stars, Gaia helps us estimate the size, temperature, and potential habitability of these distant worlds. The results have been nothing short of groundbreaking. Thanks to the combined efforts of Kepler and Gaia, we now know that our galaxy is teeming with Earth-sized planets. Hundreds of millions of them, in fact, orbit sun-like stars in the habitable zone where conditions might be just right for life as we know it. With the help of Gaia, we now know that the nearest Earth-sized planet is probably within 20 light-years of the solar system. While this might seem a vast distance in human terms, in the cosmic scale, it's practically next door. And who knows what fascinating discoveries await us there. So, how many alien civilizations might be out there? It's a question that has sparked curiosity and fueled science for centuries. We've explored ancient speculations, delved into the Drake equation, journeyed with the Kepler mission, and observed the galaxy with Gaia. Now it's time to pull all these strands together and see what picture they paint. The discovery of over 300 million worlds with conditions similar to Earth has been a game changer. Imagine, scattered throughout the Milky Way, there are millions of planets where water could pool, where life as we understand it could thrive. Think about that for a moment. The sheer scale of possibilities is staggering. Our understanding of the universe has been transformed. We've discovered that half of the galaxy's sun-like stars host rocky worlds in habitable zones. This is a far cry from the time when the existence of planets outside our solar system was mere speculation. The Drake equation, a framework for calculating the number of detectable civilizations in the Milky Way, has become less of an abstract concept and more of a real tool. We now have hard data for some of the equation's variables. We know the rate of sun-like star formation, the fraction of those stars with planets, and the number of habitable worlds per stellar system. The Kepler mission has given us insights into the diversity of exoplanets, revealing worlds unlike any in our solar system. And the Gaia Observations have helped us understand the vastness of our galaxy, showing us that the nearest Earth-like planet is probably within 20 light-years of our solar system. The exploration of space has become a quest for understanding life, not just stars and planets. We are no longer just looking up at the night sky. We are searching for our cosmic neighbors. While we may not have a definitive answer yet, the search for extraterrestrial life continues. Who knows what we might discover next?